Now let's assume that this circle is a unit circle, meaning it has a radius of 1. Okay, that means that it has a circumference of 2 pi, since circumference to diameter, the circumference to diameter ratio is pi. If the radius is 1, the diameter is 2, so the circumference then has to be 2 pi by the definition of pi. Okay, well, when we do our first subdivision, we've divided that arc of length 2 pi, that's the entire circle, into 2 parts. So each part has length what? 2 pi divided by 2. Of course, that's pi, and I know that, but we're going to just write it out in very systematic manner as 2 pi divided by the number of arcs that we've created. Okay, so when we do this division with the vertical line, now we've divided the circle into 4 arcs. Each of them has length 2 pi over 4. When we subdivide that angle, when we bisect that angle, we get an arc that has length, well, half of the 2 pi over 4 is 2 pi over 8. In other words, we will obtain an arc that's 1/8 the arc of the whole circle. It has a length 1/8 the arc length of the whole circle, and so forth. So with every division, the denominator doubles. So that in general, after n steps, we have an arc of length 2 pi over 2 to the n. Now, to get this arc here, for example, what would n have to be? We've got 1, 2, 3, 4, 5 subdivisions, and we get an arc of this length. Now, of course, we can use that arc to construct an arc twice the length. Of course, that would just give us the one that we had when we bisect this arc. Okay, but if we do this 1, 2, 3 times, we get 3 of these arcs. So we have 3 times this arc, and 3 times this arc, which would be 3 times pi over 8. And I haven't subdivided that, but anyhow, that fraction doesn't reduce. Okay, now, what's all this mean? Okay, first of all, these arcs, as we can easily see, we've always got a 2 in front of the pi in the numerator, and that'll always divide out one of the 2's in the denominator, so that the general length of an arc after n steps will be pi over 2 to the n minus 1. Okay, so the arc length after 5 steps will be pi over 2 to the 5 minus 1, that's pi over 2 to the 4th, which is pi over 16. And we've already seen that as an arc of pi over 16. If we do 2 of those, we get 2 pi over 16, which is pi over 8. Of course, that's one we've already gotten. If we do 3 of these, we get 3 pi over 16, and that doesn't reduce. 3/16 is a rational number that doesn't reduce. So on the circle, we say that we can construct points at angular positions. Well, we've already constructed pi over 2 to the n minus 1 arc, but we can do p of those arcs. Like if p is 3, we do 3 of those arcs, we get 3 over 2 to the 5 minus 1, 3/16 pi. Okay, so p is the number of times we repeat, let's say, our smallest arc, our arc at the nth step, and if we do that all the way around the circle, we get points at these angular positions, and these are the only angular positions that we can have. Now, I say the angular positions are p over 2 to the n minus 1 pi radians. Why do I say radians? Well, the radian measure of an angle is just the arc distance corresponding to that angle on a unit circle. That's really the definition of a radian, or that's one possible definition of the radian. So that is the arc distance on a unit circle. That's also the radian measure of the corresponding angle. So we can say p over 2 to the n minus 1 pi radians. These are the possible arcs that we can construct by this sort of subdivision, bisecting each arc in turn. And of course, when we say the angle is p over 2 to the n minus 1 pi radians, we don't really have to write the radians. The radian measure is there when we need it. but the default measure of an angle is the radian. So if we just write p over 2 to the n minus 1 pi and say that's the angle, that's perfectly legitimate. It's understood that that's in radians. If an angle's in anything but radians, you have to say what it is. You don't say an angle of 90, meaning an angle of 90 degrees. You have to say 90 degrees. If you say 90, you mean 90 radians. That's what that means. That might not be what you mean, but that's what 90 means without a degree on it. Okay, well, so the bottom line is, by this sort of an argument, we can say that the only possible points that we can get on the circle are the ones that have angular positions p over 2 to the n minus 1 pi radians. Okay? And the arc distances are just p over 2 to the n minus 1 pi units on the unit circle. It's interesting to note that this is always a rational number. It's always a whole number over a whole number, or an integer over an integer, actually. But pi being irrational, this is a rational multiple of an irrational number, so all these angles and all these arcs are irrational. We'll get into what that means in a minute.